Hello everyone, this is Kalpana here. In this video, we're going to solve a differential equation from higher order linear differential equation with variable equations. So let's get going. Problem solve x cube d cube plus x square d square into y equals to 1 plus x square. So here we are given a differential equation with variable equations and we are going to reduce this to a differential equation with constant equations by making some substitution, and also we are given Cauchy's equation. Given Cauchy's equation, x cube d cube plus x square d square into y equal to 1 plus x square. Now let's make the substitution. Put x equals to e power z, then log x to the base equals to z for x greater than 0. Let theta equals to d by dz. Here theta is a differential operator with independent variable z. Then xd equals to theta, x square d square equals to theta of theta minus 1. Theta of theta minus 1 can be written as theta square minus theta, and x cube d cube equals to theta of theta minus 1 into theta minus 2. Since theta of theta minus 1 is theta square minus theta, we'll get theta square into theta is theta cube minus 2 theta square minus theta into theta, theta square minus into minus plus theta into 2 theta. This is equals to theta cube minus 3 theta square plus 2 theta, right? Now the above equation becomes, replace x square d square by theta of theta minus 1 into theta minus 2 plus replace x square d square by theta of theta minus 1 into y equal to 1 plus replace x by e power z, will get e power z plus e power z whole square. Then theta of theta minus 1 into theta minus 2 is, already we have simplified, right? Theta cube minus 3 theta square plus 2 theta plus theta of theta minus 1 is theta square minus theta into y equal to 1 plus e power z plus e power 2z. Then the above equation becomes theta cube minus 3 theta square plus theta square is minus 2 theta square plus 2 theta minus theta is plus theta into y equal to 1 plus e power z plus e power 2z. So we have reduced the given differential equation with variable equations to a differential equation with constant equations, right? And also this is in operator form, f of theta into y equals to some function of z, which is in operator form, f of theta into y equals to q of z, where f of theta is theta cube minus 2 theta square plus theta, right? Now we need to find the general solution of the given equation, which is given by y equals to yc plus yp. So we need to find yc and yp. Let's find firstly yc using the auxiliary equation and later we'll go for yp. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of theta, theta cube minus 2 theta square plus theta, right? Let's replace differential operator by m, so that we'll get a f of m equals to m cube minus 2m square plus n. Then our auxiliary equation becomes m cube minus 2m square plus m equals to 0. Now we need to find roots of this equation. Take m common from all the three terms, we'll get m times m square minus 2m plus 1 equals to 0. Okay, I'll just take m square minus 2m plus 1. We can write it as m square minus, we can write 2m as 2 into m into 1 plus write 1 as 1 square. This is of a square minus 2ab plus b square, expansion of a minus b whole square, right? So we can write this equation as m into m minus 1 whole square equals to 0, or m into m minus 1 into m minus 1 equals to 0. Equate each factor to 0. We'll get m equals to 0, m minus 1 equals to 0, m minus 1 equals to 0. M equals to 0 is 1 root, and from m minus 1 equals to 0, we'll get m equals to 1. So the roots are 0, 1, 1, right? One distinct root and two equal roots. Right? We know that when we have one distinct root, then yc will be c1 equal that distinct root into z, and if we have two equal roots, say m2 and m3 are equal, then yc will be take two constant c3 and c2 and c3 will get c2 plus c3z into e power that equal root into z. Now let's write our complementary function. Yc equals to, first we will write for 0 distinct root, we'll get c1 equals 0 into z plus, now let's write for equal roots, two equal roots, we'll get c2 plus c3z into e power that equal root into z, right? Which is equals to c1 e power 0 into z is e power 0 plus c2 plus c3z into e power 1 into z is e power z, right? And also we know that e power 0 is 1, then we'll get c1 into 1 plus c2 plus c3 z into e power z. Then yc becomes c1 into 1 c1 plus c2 plus c3z into e power z. Now we are having yc in terms of z, but we need to write in terms of x, so we'll replace e power z by x and z by log x. Then yc becomes c1 plus c2 plus c3 into log x into, replace e power z by x, will get into x, which is our required yc. Let's now find yp, particular integral. We'll find particular integral using 1 by f of theta into q of z. We have f of theta and q of z, where f of theta is theta cube minus 2 theta square plus theta, and q of z is 1 plus e power z plus e power 2z. We can write it as 1 by f of theta into 1 plus 1 by f of theta into e power z plus 1 by f of theta into e power 2z. So let's now find each term separately for our convenience. I'll start with the first term, 1 by f of theta into 1. See, we are having 1 by f of theta into constant, right? We can write constant as e power 0 into z. Okay? So this equals to 1 by theta cube minus 2 theta square plus theta into 1. See, e power 0 into z is e power 0, which is equals to 1. Again, you'll get 1. Okay. So, we'll replace this 1 by e power 0 z. And this is of 1 by f of theta into e power az form. Right? We have for theta cube minus 2 theta square plus theta. Now, compare e power 0z with e power az. Then for a equals to 0, we'll find f of a, which is equals to f of 0. Just replace theta by 0, we'll get 0 cube minus 2 into 0 square plus 0, which is 0. By replacing theta by 0, we'll get the denominator 0. We'll get something like this, which is undefined, because 1 by 0 is undefined. So total term becomes undefined, right? So we won't replace theta here. We won't replace theta by 0 here. We'll just write 1z into 1 by find derivative of f of theta. If f of theta is theta cube minus 2 theta square plus theta, then f dash of theta will be 3 theta square minus 2 2s of 4 theta plus derivative of theta with respect to theta is 1, right? Since f of 0 is equals to 0, right? Now, if we replace theta by 0 in the denominator, we'll get, or just find f dash of a or f dash of 0. Replace theta by 0, we'll get 3 into 0, 0 minus 4 into 0, 0 plus 1 is 1, which is non-zero. Since f dash of 0 is non-zero, so just replace theta by 0. We'll get 3 into 0 square minus 4 into 0 plus 1 into e power 0z. This becomes z into 1 by 0 minus 0 plus 1 into e power 0z. Right? This equals to z into 1 by 1. E power 0z is 1. Write 1 directly. Or you can write it as e power 0. This is equals to z into e power 0, which is equals to z into 1, which is equals to z. So the result obtained from the first term is z. Now let's go for the second one. This is of 1 by f of theta into e power az form. For a equals to 1. Just compare e power z with e power az. Then for a equals to 1, we'll find f of a. Since f of theta is theta cube minus 2 theta square plus theta, let's find f of a, which is equals to f of 1. Replace theta by 1, we'll get 1 cube minus 2 into 1 square plus 1, which is equals to 1 minus 2 plus 1. 1 plus 1, 2 minus 2 is 0. Since f of 1 equals to 0, so we won't replace theta by 1 in the denominator, because we are getting 1 by 0 into e power z by replacing theta by 1, right? Since 1 by 0 is undefined, so total term becomes undefined if we replace theta by 1 in this. Okay, so what we'll do is we'll just write 1z into 1 by find f dash of theta. If f of theta is theta cube minus 2 theta square plus theta, then f dash of theta is 3 theta square minus 4 theta plus 1. Then find f dash of 1, which is equals to 3 into 1 square minus 4 into 1 plus 1, which is equals to 3 minus 4 plus 1. 3 plus 1 is 4 minus 4 equals to 0, right? So here also we cannot replace theta. Here I am writing f dash of theta, which is 3 theta square minus 4 theta plus 1 into e power z. Since f dash of 1 is 0, so again we'll take one more z into 1 by find f double dash of theta. If f dash of theta is 3 theta square minus 4 theta plus 1, then f double dash of theta will be 6 theta minus 4. Right? Now, find f double dash of 1. For a equals to 1, we'll find f double dash of a. Otherwise, we'll get 6 into 1 minus 4 equals to 6 minus 4. 6 minus 4 is 2, which is non-zero. So, by replacing theta by 1, we'll get 6 minus 4, which is 2, which is non-zero. Since f double dash of 1 is non-zero, so we can replace theta by 1 here. We'll get z into z, z square into 1 by 6 into 1 minus 4 into e power z. This becomes z square into 1 by 6 minus 4 into e power z, which is equals to z square into 1 by 2 into e power z, which is equals to 1 by 2 z square e power z. So the result obtained from the second term is 1 by 2 z square e power z. Now let's go for third one. This is 1 by f of theta into e power az form. We have f of theta, theta cube minus 2 theta square plus theta, right? Now compare e power 2z with e power az, then for a equals to 2, we'll find f of a, which is equals to f of 2. Replace theta by 2. We'll get 2 cube minus 2 into 2 square plus 2, which is equals to 2 cube 8 minus 2 into 2 square 4 plus 2 is 8 minus 8 plus 2, which is equals to 2 non-zero. Since f of 2 is non-zero, so we can replace theta by 2 here. We'll get 2 cube minus 2 times 2 square plus 2 into e power 2z, which is equals to 1 by 8 minus 2 into 2 square 4 plus 2 into e power 2z, which is equals to 1 by 8 minus 8 plus 2 into e power 2z, which is equals to 1 by 2 into e power 2z. So this is a result obtained from the third term. Now coming to yp. Yp becomes result obtained from the first term is z plus result obtained from the second term is 1 by 2 z square is e power z plus result obtained from the third term is 1 by 2 e power 2z. Now we are having y2 in terms of z, but we need to write in terms of x. So we'll replace e power z by x and z by log x. So in order to replace e power z by x, we need to write e power 2z as e power z whole square. First two terms remains the same. In the third term, we'll write e power 2z as e power z whole square. Now we can replace e power z by x and z by log x. We'll get log x plus 1 by 2 into replace z by log x. We'll get log x whole square into replace e power z by x into x plus 1 by 2 into x square, or log x plus x into log x whole square by 2 plus 1 by 2, or x square by 2, or log x plus x by 2 into log x whole square plus x square by 2, which is our required yp. So we got yp and yc. Let's now write the general solution of the given equation. The general solution is given by y equal to yc plus yp, right? Then y equal to yc, we have c1 plus c2 plus c3 log x into x plus yp log x plus x by 2 into log x whole square plus x square by 2. So this completes the problem. So we have seen a problem from higher order linear differential equations with variable coefficients in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.